You ever get the feeling that math has this secret language? That numbers are hiding all these cool patterns and tricks that feel, I don't know, kind of like magic? Well, today, we're going to pull back that curtain. We're going to unlock some of those secrets and show you the absolutely beautiful logic that's been hiding there in plain sight all along. Okay, so to kick things off, we're going to start with a puzzle. And it looks pretty simple on the surface, but trust me, what it reveals about how numbers work is, well, it's incredibly consistent and, frankly, pretty surprising. So I want you to actually try this with me. Grab a piece of paper or just do it in your head, because the result is going to make you step back and wonder, wait, what's really going on here? It's super simple. First, just pick any four numbers in a row. For our example, let's use 3, 4, 5, and 6. Now, here's the fun part. You get to put either a plus or minus sign in between each of those numbers. Then, just do the math and see what you get. So for instance, you could try 3 plus 4 minus 5 plus 6. You run the numbers and you get 8. Easy enough, right? But remember, that's just one of 8 possible ways you could arrange those signs. Go on, give it a shot. Try another combination. Maybe do 3 minus 4 plus 5 minus 6. Or, pick a completely different set of numbers, like 10, 11, 12, 13, and do the same thing. As you're getting your answers, pay really close attention. Do you start to see some kind of pattern? And here it is, the big reveal. No matter what 4 consecutive numbers you pick, and no matter how you mix and match those plus and minus signs, the answer is always, every single time, an even number. Isn't that wild? It feels like a magic trick, but I promise you, it's pure, beautiful logic. So, how is that possible? What's going on? Well, the secret isn't some crazy, complicated formula. It's actually based on one of the very first things we all learn about numbers: the difference between even and odd. It's time to unmask the magic. This whole thing boils down to a really cool concept with a fantastic name: parity. All parity means is whether a number is even or odd. That's it. And the simple rules of parity are what's controlling the outcome of our puzzle every single time. And these are the rules of the game. They are super simple and they never, ever break. If you add or subtract 2 odd numbers, you always get an even. 2 evens also gives you an even. The only way you can end up with an odd number is if you mix and match 1 even and 1 odd. These are the fundamental laws we're working with. Okay, now this is the absolute key to the whole thing. Whether you add 2 numbers together or subtract them, the parity, whether the answer is even or odd, is exactly the same. An odd plus an odd is even, right? Well, an odd minus an odd is also even. This little fact is the master key to our puzzle. And that right there, that's why the trick works. Since swapping a plus for a minus never changes the final parity of the answer, all 8 of those possible calculations are linked. It's a chain reaction. They all have to be even or they all have to be odd. And since we already found one combination that equals an even number, our example that came out to 8, then all of them have to be even. It's guaranteed. Pretty cool, right? Just understanding this simple property of even and odd numbers cracks the whole case. And that same basic idea that there are hidden rules governing how numbers behave is also what explains some of those other math tricks you probably had to memorize in school, the divisibility rules. Oh yeah, you remember these. A number is divisible by 2 if it ends in an even number. Check. Divisible by 5 if it ends in a 0 or a 5. Yep. And then there's that slightly weirder one. A number is divisible by 9 if you add up all its digits and that sum is divisible by 9. Come on, let's be honest. We all memorize these rules to get through a math test. But did anyone ever stop and explain the logic behind them? Like, why in the world would adding up the digits of a number tell you anything about whether it's divisible by 9? It seems totally random, but it's not. So, we're going to crack the code on what I think is the most fascinating one of them all, the rule of 9. Because when you understand this one, it reveals something really beautiful about our entire number system. So here it is again. It's a rule we all know, but the reason it's always true is just it's surprisingly elegant. Let's break it down. Okay, you ready for the secret? It's all about how our powers of 10, 10, 100, 1000, relate to the number 9. 10 is just one more than a multiple of 9, right? It's 9 plus 1. 100 is 99 plus 1. 1000 is 999 plus 1. You see the pattern? This simple relationship is everything. So let's take a random number. How about 7,309? We can write it out the long way, like 7 times 1,000 plus 3 times 100 and so on. Now watch this. We're going to replace each of those powers of 10 with our new multiple of 9 plus 1 version. So 1,000 becomes 999 plus 1. 100 becomes 99 plus 1. We haven't changed the number. We've just rewritten it in a really clever way. Now, if we rearrange that equation a little bit, we can sort it into 2 piles. In this first column, we have all the parts that are guaranteed to be multiples of 9, right? 7 times 999 is obviously divisible by 9. So what are we left with in the other column? Just 7 times 1, 3 times 1. These are the leftovers. And look, it's just the original digits of our number. And there it is. That's the aha moment. Since that entire first chunk of the number is already divisible by 9, the only thing we need to check is that little pile of leftovers. And that pile of leftovers is just the sum of the digits. That's why the trick works. And get this. Here's a little bonus. This exact same logic is why the divisibility rule for 3 works too. Why? Because any number that's a multiple of 9, like 99 or 999, is automatically a multiple of 3. So the same exact trick applies. How cool is that? One piece of logic just unlocked 2 different rules. So as you can see, what feels like some kind of weird math magic or a strange coincidence is actually built on a foundation of pure, simple logic. It's not magic at all, it's just about learning to see the system from the right angle. And that really gets to the heart of what this is all about. This quote says it perfectly. The goal isn't just about memorizing shortcuts to get an answer. The real power, and honestly the real fun, is in understanding why these things work. That's when you really start to speak the language of numbers. So to wrap this up, and to put your new logical toolkit to the test, I want to leave you with one final challenge. It's an old riddle, but now that you understand a little more about divisibility and logic, you'll be able to see it in a completely new light. Here it is. I hold some pebbles. When grouped in 3s, 1 stays. Pair them up, 1 remains. Group them by 5, 1 is still around. But grouping by 7, perfection is found. More than 100 would be far too bold. How many pebbles do I hold? Think about remainders, think about divisibility, and see if you can crack the code. Thanks for